To travel beyond the solar system to the nearest star would require a journey of more than 5 trillion miles. Yet our sun is only one of 100 billion stars, widely separated from one another in time and space, but all bound by gravity, and all revolving around the central core of our galaxy, the Milky Way. Drifting between the stars are vast clouds of gas and dust, the nebulae, made luminous by the radiation of stars within or near them, or darkly obscuring the light of whatever lies behind them. Here, new stars are being born. About a half-century ago, our galaxy was thought to be alone in the universe. We now know it to be one of a local group of about 20 galaxies. And strewn through the vast reaches of space are more than 10 billion galaxies, grouped in clusters as far as our most sensitive instruments can reach. Little is known about the evolution of galaxies, and why some are formless or irregular, others elliptical, and still others spiral-shaped. And we know as little about the galactic core and its role in the galaxy's evolution and structure. The problem has become more perplexing by the discovery that some galaxies are in a state of extreme disarray, exploding, ejecting gaseous matter, or interacting with other galaxies. Even more puzzling are quasars, star-like objects, emitting as much energy every second as the sun radiates in some 10 million years. They appear to be among the most remote objects in space. Stars are born, live out their lifespans, and die. The life history of a star is marked by an opposition of two kinds of pressure. One is the pressure created by the energy in the core of the star, pushing the surface outward. The other is the crushing force of gravity pulling the star's surface inward. When these are balanced, a star becomes stable and shines steadily. As hydrogen fuel is depleted, the release of energy is insufficient to withstand the gravitational pressure, and the core collapses. But compression by gravity raises the temperature in the core, and helium ash rekindles the nuclear fires. Vast amounts of energy are released and lift the outer zones against the force of gravity. The star is now a red giant. In the final stage of its evolution, it is the mass of a star that determines its fate. The Sun, a medium-sized star, remains stable for approximately 10 billion years. Then it will expand to 400 times its present diameter. As it expands, it will engulf the inner planets, Mercury, Venus, Earth, and Mars, and create a nebula extending past the outer planets. After millions of years, its reserves of nuclear fuel will be exhausted, its outer layers will have dissipated, and only a white dwarf star remains, no larger than the Earth. Slowly cooling to zero temperature, it will end its life as a black stellar corpse. When a star more massive than the Sun reaches the red giant stage, the collapse of its core raises its temperature billions of degrees and triggers a spectacular detonation. A supernova explosion. At the center of the explosion, a residue of the star is crushed by gravity to a neutron core, only a few miles across, but so dense that 10 billion tons of its matter would fill only a tablespoon. It spins rapidly, generating radio signals in its strong magnetic field. And a radiation beam sweeping past the Earth is observed as a pulse. The star is known as a pulsar. An even stranger end is predicted for very massive stars. According to the laws of gravity as presently understood, nothing can stop its collapse. The star disappears from our universe, leaving a black hole in space. Its presence can be deduced only by its influence on a visible companion star, distorted out of shape by the black hole's gravitational attraction. Gas, pulled off the visible star, circulates about the black hole, and in the dizzying plunge, it emits X-rays which can be detected in space. No light or matter can ever leave the intense gravitational field of this cosmic abyss. The physical laws that govern the conditions within this bizarre object are totally unknown to us. The evolving universe itself must come to an end. If it continues to expand indefinitely, the light of every star will in time be extinguished, and the galaxies will disappear into infinite darkness. But if gravity halts the expansion, the universe will fall back on itself. Galaxies will lose their separate identities. Stars will explode, and the sky will again be ablaze with light. Finally, all matter will be engulfed in a fireball like that from which it emerged. All things on Earth, living and inert, are formed from the elements forged in some distant and unknown star. On Earth, atoms joined together in definite numbers and patterns compose the organic molecules which form living cells. Since the discovery of complex molecules in the chill vacuum of interstellar space, there is reason to believe that among the countless galaxies in the universe, there are stars orbited by planets favorable for the evolution of intelligent life. Is space travel to these planets possible? Time and distance may be insurmountable barriers. A more practical strategy in the search for extraterrestrial life is to tune in on radio signals traveling at the speed of light, beamed perhaps by creatures on the planet of some distant star. Someday, an array of telescopes, earthbound or lifted to the far side of the moon, may hear faint but unmistakably meaningful sounds amidst the din of cosmic radio chatter. That moment will signal a change in the human condition that we cannot foresee or imagine. For man, wrote H.G. Wells, there is no rest and no ending. He must go on, conquest beyond conquest. And when he has conquered all the deeps of space and all the mysteries of time, still he will be beginning.